And hello there everyone, thanks so much for joining us on our special coverage of China's lunar mission. I'm Zhong Shi, coming to you live in Beijing.
A Chinese rocket is on its way to the moon with a mission to bring back rock samples back down to Earth.
The space race has reluctantly accepted a third competitor, China. Even though the US and Russia have a head start in the fight for supremacy in space, China is obliterating any doubt as to its prowess with a series of shocking discoveries. The latest is the terrifying new discovery on the moon by China, which changes everything we thought we knew about the satellite. Stay tuned as we bring you all the details in this video. When many people think of the moon, they hardly think about water. However, a new discovery by China may finally show the presence and origin of water on the moon. According to scientists, the moon's formation was a turbulent process full of cataclysmic events and collisions on an astronomical scale that eventually led to the creation of our closest celestial neighbor. And this celestial story is not only captivating but also gives us crucial insights into the early solar system and the formation of our own planet, Earth. Around 4.5 billion years ago, during the Hadean era, the entire solar system was a tumultuous place. Planets, protoplanets, and other celestial bodies were engaged in a chaotic dance, resulting in many collisions. Earth, still in the early stages of formation, was not exempt from these violent interactions. And the moon's genesis story begins with one such cosmic collision. According to the leading theory known as the giant impact hypothesis, a Mars-sized celestial body dubbed Theia struck Earth in a glancing blow. The sheer force of this impact was unimaginable enough to vaporize Theia and eject a significant portion of Earth's mantle into space. This event also set Earth spinning at a much higher rate than today and could be responsible for the axial tilt our planet currently has. The colossal collision's aftermath resulted in a ring of molten rock, dust, and debris orbiting the young Earth. The materials consisted of remnants from both Earth and the obliterated Theia, heated to extremely high temperatures from the energy of the impact. This debris ring was the raw material from which the moon would eventually form. The process of the moon's formation from the debris ring is best described as a grand cosmic ballet performed over the course of several million years. The fragments within the debris ring gradually started to coalesce through a process known as accretion. The particles, drawn together by gravitational forces, began to clump together, growing larger over time. As these clumps grew, they began to form larger bodies, which attracted more particles and continued to increase in size. This process continued until most of the debris had been accumulated into a single celestial body, and thus the moon was born from the remains of a catastrophic collision. In the early years of its existence, the moon was likely covered in a magma ocean, a molten rock layer that eventually cooled and crystallized to form the crust we see today. However, the surface of the moon was continually bombarded by comets, asteroids, and meteorites, creating the craters, mountains, valleys, and lunar seas, or maria, we observe from Earth. And over the intervening billions of years, tidal forces have shaped the Moon-Earth relationship. The moon is tidally locked to Earth, meaning it always presents the same face to us. It is also gradually receding from Earth at a rate of about 1.5 inches per year. This ongoing movement is due to the leftover momentum from the initial impact that created the moon and the resulting gravitational interactions. But what about water on the moon? At what point did that enter the picture? There are several theories about the presence of water on the moon. One theory suggests that water was created by the impact of meteorites slamming into the surface of the moon. The water was either carried in on the meteorites, or the collisions transformed existing hydrogen and oxygen in the soil into water. This water was either trapped in glass beads or frozen in areas that had never seen the sun. In the late 2000s, a number of missions, including the Indian space research organizations Chandrayaan-1 and NASA's Cassini and Deep Impact, detected hydration on the lunar surface, but these missions could not determine if the signals were hydroxyl or water. And during this same time period, using ultra-high precision laboratory equipment, scientists also found water molecules locked in glasses and minerals in the samples returned by the Apollo missions. And then, in 2019, data from the LADEE mission revealed that OH and/or H2O existed on the Moon beyond the permanently shadowed regions and is expelled through micrometeorite impacts. Now, China took a minor but crucial step towards becoming a space power less than 2 years ago. For the first time, the Asian behemoth deployed a robotic spaceship to Oceanus Procellarum, Latin for Ocean of Storms, a gigantic lunar mare that appears to Earth as a massive dark area. According to the China National Space Administration, it is the Moon's youngest terrain. The Chang'e 5 probe from China landed near Mount Rumke, a 43-mile-long or 50-kilometer mountain rising about a mile above the horizon. China's Chang'e 5 lunar lander is a crucial part of China's daring sample return mission, and the spacecraft recently made a historic discovery. It became the first spacecraft to detect water on the Moon at its landing site in real time. Chang'e 5 found water at its landing site near Oceanus Procellarum on the Moon's near side, using an instrument that detects water by determining spectral reflectance measurements of regolith or soil and rocks. The instrument was designed to look for water, and the researchers used a thermal correction model to account for the heat at the lunar surface. This allowed them to see the water signature pop out at 2.85 micrometers. The probe then took lunar samples using a robotic arm and sent them to the orbiting module above the Moon. They were then returned to Earth from there, and all of this happened in a single lunar day, which is about 14 Earth days. The study of these samples, the first collected since the Soviet mission Lunik 24 in 1976, has yielded some unexpected results. The Chinese Space Agency claims it has solved one of the Moon's biggest mysteries: where does lunar water come from? Now, as previously mentioned, the Moon was most likely formed when a planet the size of Mars collided with Earth around 4 billion years ago. The collision shattered a chunk of the Earth and coated it in molten rock. Now, it was thought that the temperatures were so extreme when this happened that all water evaporated permanently from the Moon. However, multiple robotic missions and terrestrial telescopes have proved in recent years that the Moon still has water, and not just a few drops. There are tons of water in the form of ice. Much of this water is at the poles, where it's perpetually dark. And NASA intends to land the first crewed mission to the Moon in 50 years precisely in these uncharted regions. The expedition is landing there because the area includes water which might provide sustenance and raw material for rocket fuel to assist humans who may one day travel to Mars. Now, it was previously unknown where this frozen water originated from, and other space probes discovered ice in the sunlit portions of the Moon but were unable to identify how that got there as well, with researchers speculating that it may have arrived through an asteroid or a previously unknown water reservoir. However, scientists from the Chinese Academy of Science, CAS, in partnership with 2 European experts, say in a report released recently that the clue to the formation of lunar water resides in the samples sent by Chang'e 5. These samples taken from the Moon's northwest contain impact glass beads, which are microscopic grains of varied colored glass that formed at high temperatures after a meteorite crashed with the Moon. The glass beads gathered by Chang'e 5 contain trace levels of water, according to the study, which was published in the journal Nature Geoscience. According to Sen Hu of CAS's Planetary Physics Laboratory, the water concentration in the crystals is around 2,000 parts per million, or roughly 2,000 grams per ton of soil. On the Moon, meteorite impacts are very frequent and occur across the Moon, meaning glass beads are distributed throughout its geography from the equator to the polar regions. The lunar water may be in its molecular state with 2 hydrogen atoms and 1 oxygen atom, while hydroxyl, 1 hydrogen and 1 oxygen atom, are likely more plentiful. Researchers believe that 270 billion tons of water could be stored in the form of impact glass particles across the moon. In comparison to other estimations, this is a massive reservoir. A NASA radar aboard the Indian probe Chandrayaan-1, for example, estimated in 2010 that there were approximately 600 million tons of ice entombed in craters at the moon's north pole. The samples gathered by the Chinese spacecraft are around 8 billion years younger than those collected by astronauts in the United States Apollo program and the Soviet Union's robotic missions. According to the current research, these glass beads have been forming for the past 2 billion years, with more being formed during periods of violent meteorite collisions, such as the one that occurred 68 million years ago, when a massive meteorite collided with Earth and killed the dinosaurs. Now, what's fascinating, according to Hugh, is that the water trapped in the lunar crystals was created by the sun. According to the study of the different sorts of hydrogen atoms in the samples, positively charged hydrogen atoms from the solar wind pierced the glass beads and interacted with the oxygen inside them. And when the temperature rises due to the sun's radiation, these glass beads may release some of their H2O charge. It is these glass beads that are responsible for the water cycle on the moon. Now, this could be an alternative water source, and the best way to extract it would be to collect lunar soil, heat it in an oven at 100 degrees Celsius, and then capture the resulting steam. And while it may appear absurd, Europe's Prospect spacecraft is being dispatched to the moon to achieve exactly that. A probe will dig into the lunar soil, collect samples, and heat them to 100 degrees in order to examine the volatile substances there, including water vapor. This project, which will launch in 2026, can clarify whether there is water trapped on the minerals on the moon, according to James Carpenter, head of planetary sciences at the European Space Agency. The latest China-led study, according to Carpenter, provides an important demonstration that water is trapped in lunar glass beads spread across the entire surface. However, because the amount of this element is so little, a lot of lunar soil would have to be processed if it were to be useful to future manned missions. As such, these glass beads are probably not an exploitable water reservoir, Carpenter concluded. Nevertheless, this research provides clear proof of the moon's water cycle, including the likely formation of frozen reserves near the poles. Now, the atmosphere of the moon is so thin that the molecules hanging in it never interact. As a result, when the sun hits the glass beads, water vapor is ejected like a cannonball, according to Carpenter. Water tends to stay longer in the coldest and darkest places, which explains why it's accumulated as ice at both poles of the moon. But why is there so much excitement about the discovery of water on the moon? To start with, the discovery of water on the moon could have important implications for future space exploration. Water is a valuable resource in space, and its presence on the moon could make it easier for humans to establish a sustainable presence there. Water can be treated and used for drinking, separated into hydrogen and oxygen for use as a rocket propellant, and the oxygen can be used for breathing. Having access to water on the moon could also reduce the cost and complexity of future missions. Instead of having to transport large amounts of water from Earth, astronauts could use the water that is already present on the moon. This could make it easier to establish a permanent base on the moon and could also serve as a stepping stone for further exploration of the solar system. In addition to its practical uses, water on the moon could also have important scientific implications. The presence of water on the moon could provide clues about the history and evolution of the solar system. By studying the water on the moon, scientists could learn more about how water is distributed throughout the solar system and how it may have played a role in the development of life. The discovery of water on the moon also opens up new possibilities for international cooperation in space exploration. Countries and space agencies could work together to establish a permanent base on the moon using the water that is present there to support their operations. And this could lead to new scientific discoveries and technological advancements, as well as foster greater cooperation and understanding between nations. Now, there is another fascinating discovery by China on the moon made by the Yutu-2 rover, the first spacecraft to explore the surface of the moon's far side. The rover landed in Von Karman crater atop the Chang'e 4 lander and has been working its way northwest during each 14.5 Earth Day long lunar days ever since. using its 4 science payloads to image and analyze its surroundings as it goes. Yutu-2 is a lunar rover that's part of China's Chang'e 4 mission. The rover landed on the far side of the moon in January 2019 and has been exploring the lunar surface ever since. Yutu-2 is equipped with a variety of scientific instruments that allow it to analyze its surroundings and make discoveries. These instruments include a panoramic camera, a lunar penetrating radar, a visible and near-infrared imaging spectrometer, and an infrared imaging spectrometer. The rover is powered by solar panels, which provide energy for its operations during the lunar day. During the lunar night, when temperatures can drop to minus 180 degrees Celsius, minus 292 degrees Fahrenheit, the rover goes into hibernation mode to conserve energy. Yutu-2 is operated remotely by a team of scientists and engineers on Earth. The team sends commands to the rover, which it executes autonomously. The rover then sends back data and images which are analyzed by the team to plan its next moves. And during its journey, Yutu-2 came across a curious rock specimen which the Yutu-2 drive team began to refer to as a milestone. According to a Yutu-2 diary published by Our Space, the Chinese language science outreach channel affiliated with the China National Space Administration (CNSA), mission scientists agreed with the drive team that the elongated rock was worth closer inspection. The team then planned to make a close approach and analyze the rock with Yutu-2's visible and near-infrared imaging spectrometer (VNIS) instrument, which detects light that's scattered or reflected off materials to reveal their makeup. VNIS has been used to investigate a number of rocks and regolith samples along Yutu-2's path across the von Karman crater. While not looking particularly exciting to the untrained eye, the find has generated interest among lunar scientists. It seems to have a shard-like shape and is sticking out of the ground. That's definitely unusual, according to Dan Moriarty, NASA postdoctoral program fellow at the Goddard Space Flight Center in Greenbelt, Maryland. Moriarty said both the shard-like shape and the pronounced ridge running near the edge of the rock seem to indicate that this rock is geologically young and was in place relatively recently. Repeated impacts, stresses from thermal cycling, and other forms of weathering on the lunar surface would all tend to break down rocks into more or less spherical shapes given enough time, Moriarty stated. But what really caught the attention of the researchers were 2 translucent glass globules found on the surface of the rock. The rover's panoramic camera spotted the 2 glass spheres as it drove across the surface of the von Karman crater. The globules are between 15 and 25 millimeters across, much larger than the tiny glass beads found previously in lunar samples brought back by the Apollo astronauts. The researchers believe that these glass globules were probably formed by relatively recent meteor impacts. Specifically, they believe that the globules formed from northosite, a volcanically formed rock rich in the mineral feldspar, after a high-energy impact melted the rock and reformed it into spheres. Xiao described the new finds as the first discovery of macro-sized translucent glass globules on the moon. Finding these spheres on the moon suggests that impact events on other planetary bodies could also form similar impact glasses, Xiao said. And on the moon, Xiao said that such glass spheres should be commonly produced by ancient impacts and could be valuable for understanding early lunar impact history. And China has made another exciting discovery on the moon, a new lunar mineral in the form of a crystal lurking inside samples collected from the moon. Chang'e Y, named for the mythological Chinese goddess of the moon, Chang'e is a phosphate mineral and columnar crystal. It was found in lunar basalt particles being examined in laboratories in China. This discovery is significant because it marks the first time that a new mineral has been discovered on the moon by China. The discovery of Chang'e Y adds to our understanding of the composition and history of the moon and could provide valuable insights into its formation and evolution. Chang'e Y is a transparent crystal that is roughly the width of a single human hair. It formed in a region of the moon that was volcanically active around 1.2 billion years ago. One of the primary ingredients found in this crystal is helium-3, which scientists believe may provide a stable fuel source for nuclear fusion reactors. The discovery of Chang'e Y is an exciting development in our understanding of our closest celestial neighbor. It opens up new possibilities for exploration and discovery and brings us one step closer to unlocking the secrets of the moon. Now, China's next mission is the Chang'e 6, a planned robotic lunar exploration mission that's expected to launch in 2024 and perform China's second sample return mission. Like its predecessors, the spacecraft is named after the Chinese moon goddess. The mission will target the South Polar Aitken SPA basin on the far side of the moon, a colossal ancient impact crater that holds vital clues about the history of the moon and the solar system. The SPA basin is considered to be the oldest on the moon and could contain rocks that are different from those collected by previous missions. The Chang'e 6 probe will consist of an orbiter, a lander, a lunar ascent vehicle, and a re-entry capsule. The lander will collect about 2 kilograms or 4.4 pounds of samples from 2 meters below the surface and place them in an attached ascent vehicle to be launched back into lunar orbit. The ascent vehicle will then make a fully autonomous and robotic rendezvous and dock with an orbiter where the samples will be robotically transferred into a sample return capsule for their delivery to Earth. The mission will also carry a number of payloads from international partners, including France, Italy, Sweden, and Pakistan. These payloads will study various aspects of the lunar environment, such as dust, volatiles, water ice, negative ions, and laser ranging. The mission is expected to be launched by a Long March 5 rocket in 2024 from Wenchang Satellite Launch Center on Hainan Island. The mission will also need the help of a relay satellite beyond the moon to communicate with Earth, as the far side of the moon never faces Earth due to tidal locking. The Chang'e 6 mission is part of China's ambitious lunar exploration program, which aims to facilitate a crewed lunar landing in the 2030s and possibly build an outpost near the lunar South Pole. The mission will also contribute to the scientific understanding of the moon and its formation and evolution. The Chang'e program is being carried out by the China National Space Administration and aims to achieve a number of milestones in lunar exploration, including orbiting, landing, and returning samples from the moon. The program is divided into several phases, with each phase building on the achievements of the previous one. The first phase involves sending orbiters to the moon, which was achieved with the successful launches of Chang'e 1 in 2007 and Chang'e 2 in 2010. The second phase involved landing and roving on the moon, which was achieved with the successful landing of Chang'e 3 in 2013 and its rover U-2. The third phase involved collecting lunar samples and returning them to Earth, which was achieved with the successful launch of Chang'e 5 in 2020. And the fourth phase involves establishing a robotic research station near the moon's south pole.